This session is on object-oriented programming concepts. So it's a programming style, that brings you the below concepts. All these concepts has been previously discussed in our sessions. So it is just going to be a kind of a recap of all those topics, whatever has been discussed. It's kind of effort to put together all these things and bringing all the concepts together, whatever has been discussed before. So as I said, this is a programming style, where it is followed by C++, Java, and few more languages. Before this object-oriented programming, which basically revolves around the object, we were doing some other type of programming which is called the structured programming, which is done in Basic, Pascal, and C. So they are all structured programming languages. Um, but Java and C++ and other few languages are all object-oriented programming languages. So the basic thing of object-oriented programming language is object. So we know what is an object. It's basically going to have a state and a behavior. Let's first see what are all the concepts we have, like we discussed before, which is objects, class, inheritance, polymorphism, abstraction, and then encapsulation. So these are the major building blocks, or I would say the concepts that forms the object-oriented programming. And any object-oriented programming that you take will be having these concepts in it. So the fundamental thing is object, which is going to have the state and the behavior. So state represents basically the properties, and behavior is the methods basically, which is going to work on the properties. So we first observe any objects like a person, who is having a name, age. These are all this is the state, actually state of the object. And we observe the actions that he can do, like he can walk, he can run. Those things are the behaviors basically. So any object will have a state and a behavior. So we first identify objects around us. Everything around us is going to be an object. It can be a physical or a logical entity. So they can be represented as an object. So if you find any similarities in two objects, like you're seeing one person and another person, and if you are able to establish some common properties among them or common behaviors among them, you are just going to put it together and create a class. So what is a class is going to be a general blueprint of the object. So if I say person class, you know it says a person should have name, a person should have age, so which means it's this, and a person should be able to walk. So this is all the behaviors and the the properties that we define as a kind of a common thing, as a kind of a blueprint, as a kind of a skeleton. So whenever I define that skeleton, any object of the class will be having those properties. So I define if you have to be a person, you should have these properties, you should have these behaviors. That is what comprises a class. A class is a representation of an object. It's a blueprint basically, where we are saying this is how the object will have, and object is the actual entity, like which is going to be created from the blueprint. Then we move on to inheritance. Inheritance is basically which is going to provide you reusability. So we don't need to provide you know um, if there is a parent class, and there is a child class will have very very common properties of the parent class. It will be basically having the same properties of the parent class. Additionally, it will have its own properties. So a best example would be person and employee. So employee is a person. It satisfies the is a relationship. So employee is a person in the sense, employee is going to have all the properties of person along with his own properties. So person is having a name, age. Employee is also going to have name, age. Along with that, he will be having an employee ID, or he will be having a salary, which is its own properties. Employee can be extended by manager. Manager is again a class. We can say manager is an employee. Employee is a person. So manager will have all the properties of employee, plus he will have his own properties. Basically, manager will be having some reportees under him. Employees need not have it, but manager should have that. That is an additional property, he may get it actually. So like that we can do inheritance using Java. In Java we support only the single inheritance and multi-level inheritance. We don't support multiple inheritance. So multiple is like, you have father and mother and a child. So child will be inheriting the properties of father and mother. That concept is not supported in Java. You can just inherit from only one class, not from two classes. A child class can inherit from only one parent class, not two classes. But that is indirectly achieved in Java via interfaces. Okay, but through inheritance you can only extend one class. And the basic function what inheritance provides you is reusability. I don't need to redefine all the fields that I have defined in the parent class again in the child class. All that I need to say is extends keyword, which is going to get me the properties of the parent class to the child class. The next item is the polymorphism. So we discussed two types of polymorphism. One is the compile time polymorphism and runtime polymorphism. You can also call it as overloading, overriding, or we can also call it a static binding and dynamic binding. All these terms are quite related to the same thing. Polymorphism means doing making many forms actually. So as the name indicates, you make multiple forms. So you behave one time different, other time in other place you will behave differently. So depending on the situations out there, that is what you call it as multiple forms of a person. So here, in terms of technical wise, we do overloading and overriding. So overloading means there is a function or there is a method where the method name will be same, but it will be having different number of arguments or different types of arguments. So an example would be you can take a sum function. The sum function can take and add two integers. It can also add three integers, or it can add two doubles. So, but I don't want to give different function name for all these things. I will have like some two integers. I don't want to have a function name like some two integers, some three integers, some two doubles, because all that it is doing is the same function, just adding two numbers, right? So I can keep the method name as sum, but the number of arguments or the data type of the arguments can be changing. So that is what we call it as overloading. So the same method name but different number of arguments or different types of arguments. What is overriding means it comes with inheritance. Suppose parent class is there and child class is there. Parent class is implementing a method. So by default, the child class can inherit that method. It doesn't need to redefine the method. So because it's already in the parent class, it can reuse the method. But this child does not want to use the parent's method. It needs to do its own way. It needs to provide a own way of implementation. So it can basically do a overriding there. So it is redefining the method in the child class. So we talked about overriding prints, what are all the other things we can have. You can have a superclass reference pointing to a subclass variable, which helps us, to do a lot of things when in Java, which is a very important topic in Java. Um, so overriding, again, to take an example, let's say we have a bank class which is going to have a general calculations for monthly payment, actually monthly mortgage payment. But a specific bank, in order to, can override that calculations and provide attractive rates to customer. So that is what you call it as a overriding. And coming to abstraction, abstraction stands for providing essential details, for the users. Like you don't need to provide unnecessary details. For example, take a car. All that I need to know about a car is how to drive a car, how to basically how to steer, how to accelerate, how to brake, and then how to adjust my gear. I don't need to know about the internals of the car, like how the engine works, how the brake pedal, what happens when I press the brake pedal, what are all the things internally happening. I don't need to know about it as a end user. So I will be, that is abstracted from me. All that I need to know is only the essential details. So that is what abstraction provides us. Abstractions in Java can be achieved by abstract classes and interfaces. We talked about abstract classes where the class will be abstract. It means it is at least going to define a method which says that, define an abstract method which says, I know that, I know what I need to do, but I don't know how to do it actually. That will be done by my subclasses. And abstract classes mandates its subclasses to implement that method. Otherwise, that subclass will also become abstract. So in overriding, it is basically optional. You may or may not override the the method, because if you override, you are providing additional definition for the method. In abstract class, you just declare a method. You will not provide a method in the parent class, which means the child class has to provide an implementation. So the best example would be, take an example of vehicle. The vehicles, we say, like vehicle class can say, I should have a drive method. It says what here, a vehicle will have a drive method, but vehicle will not give an implementation of drive method, because that is the responsibility of each vehicle, which is, a bus will be driven, in a different way compared to a flight actually, right? A bus will be extending vehicle and flight will be extending vehicle, but they don't need to, they have to implement the drive method, but the implementation will be different. Vehicle cannot provide a general implementation like, for the drive method. Only the bus or car or train has to give that implementation. But vehicle knows that any vehicle should have a drive method, so it knows what, but it does not know how. So that how part will be done by the subclasses, who implement this, who extend this class, but the what part will be defined by the abstract class. So from a end user perspective, it gives a great idea, like, by seeing the abstract class, any implementation of this abstract class will be, implementing this drive method, but he can code for the, he can code the logic with the abstract class reference. That means the vehicle reference he can code, but the real object he can get, it can be any vehicle. So he will say vehicle v equals new car of. So he can write a method for v dot drive, but the v can be anything. It can be a car, it can be a flight, whatever it is. Then coming to the interfaces, interfaces is just a pure abstract class. In abstract class there can be some defined methods, some undefined methods, whereas in interfaces it's going to be a pure abstract class where every method is not going to be defined. Interface just says what needs to be done. It's basically, it can be thought as a contract. So the contract is something between the end users and the implementers. So let's take the same example of car. Car says, gives the contract, like there is a drive method, there is a brake method, there is a steer method, there is a change gear method. So that is a contract between the driver or the user and the implementer. Like take a Honda CRV, they will be taking this interface and implementing these methods. So the internal logic, how they implement, is not even needed to the user. The user worries about only the interface part of it, how to use that interface. Implementer worries about how to implement that interface. So the interface is a contract which is binding together these two parties. And finally, the encapsulation. So we said the data members has to be private, so that is going to promote the data hiding. So otherwise we will be losing control over the data. So the data has to be secured and made it as private, and so that we will have more control on the data. So this can be achieved by making the data members as private and providing the getter setter methods, which can be updated later in case you need more control on the data. So all these concepts is going to comprise the OOP. So this OOP is going to be, this is the same concept which you go to any language, they will be having these concepts, because these are the basic concepts that is provided by the object-oriented programming language. So this has been discussed in the previous videos, whatever we discussed. So this is just kind of putting it together. You can refer to the previous videos if you have any questions on any topics which is listed here.